In this video, I'm going to show you how to manage EDI files of the same type and versions coming from multiple trading partners with different specifications in their implementation guideline. So let's say we have two trading partners, trading partner A and trading partner B, and we'll be receiving EDI files from them of the same document type and version. For example, this EDI file is from trading partner A, while this one is from trading partner B. Both these EDI files are EDIdEv invoice documents version S93A. Let's view them in Notepad. Partner A, invoice S93A. Partner B, invoice S93A. Okay, so both these files are invoices of the same version, coming from different trading partners with different specifications for their EDI files. How are we going to process them correctly and efficiently? Well, firstly, we have to create CEF files for each trading partner following their implementation guideline. I have made previous videos of how to do this, and you can find their links below in the description field. So this CEF file is from trading partner A, and this one is from trading partner B. Let's open them up with the CEF manager. Now, it's important to name the CEF files uniquely in their INI section, because this is how we will reference the schematics. In this case, I have given them the same name as their physical file name without the extension. Also, for the sake of simplicity, the only difference between these CEF files is that for trading partner A, this RFF segment is mandatory as indicated by the must use, while for trading partner B, the same RFF segment is marked not used. Now let's test the EDI files using the eFile Manager to see if the EDI files comply with the guidelines specified in these CEF files, and if we do get any errors. This is the EDI file for trading partner A. So I am going to use the CEF file for trading partner A. And I get no errors. This is the EDI file for trading partner B. I'm going to use the CEF file for trading partner B. And we get no errors. Now let's see what will happen if we don't use their corresponding CEF file, but use each other's CEF file. So this is trading partner A. going to use trading partner B's ZEP file. This time we do get an error. Data segment RFF in loop RFF is encountered, but has been specified as not used, so that's correct. And if we use trading partner B EDI file, and use trading partner A's ZEP file, we also get an error. Missing mandatory segment in EDI file RFF is expected. So this tells us if we create a solution to validate these EDI files using their correct ZEP file, we should have no error messages. If we do get error messages in our validation results, then our program has not managed the EDI and ZEP files correctly. Okay, now let's open an example program that shows 3 ways of validating these EDI files coming from 2 trading partners with different specifications in their EDI guideline. Okay, so this is a C# Windows form with 3 buttons, 1, 2, 3, having different algorithms in validating the EDI files. Let's look at the first one, which will validate the EDI files correctly, but the method is inefficient. This algorithm checks the inbound folder for an EDI file. If it finds one, it instantiates an EDI document object, then defines its settings, loads the appropriate ZEP file, then loads the EDI file before it continues with the validation process. It then disposes of the EDI document object. If it finds another EDI file, then it creates another EDI document object and does the same steps of redefining its settings and loading the ZEP file and validating the EDI message. This method is inefficient because each time we're reading an EDI file, we are recreating an EDI document object and loading the ZEP file, only to destroy it in the end. Let's run this program. Let's click the button to start. It's done. The inefficiency is not noticeable because we only had 2 EDI files. But had we had more files, then the slow performance would be noticeable. Now let's look at a more efficient algorithm. In this logic, the EDI document object is created and its settings are set and all CEF files are loaded before and outside the loop of obtaining an EDI file. This avoids having to recreate an EDI object and loading a CEF file each time we go through this loop of obtaining the EDI file. Note that when we load a CEF file, the schematics must be parsed, and this takes a few seconds, which can add up to hours if we had thousands of EDI files to read. This algorithm is efficient because it loads and parses the CEF file only once, unlike the previous code that loads the same CEF file every time an EDI file is obtained. However, this logic would work only if the EDI files were different types, for example, orders and invoices, or different versions of invoices, or if their EDI guidelines were the same, then they can share one common CEF file. But in this case, the EDI files are of the same type and version, and their specifications different. There are also no provisions in this code to manage what CEF file to use for an EDI file. And in this case, since the EDI file is an invoice S93A, and both these CEF files are for invoice S93A, then the Freddy component will use either of them. Whatever schema is active in memory, the Freddy component will use it to process an EDI file if the type and version match. This, of course, is a problem because the specifications in these CEF files are different. Let's run this code and see what happens. It's done, and we do get an error message. This proves that one of the EDI file was validated with the wrong CEF file, because had the EDI file been validated with their corresponding CEF file, there would have been no error messages. Now let's look at the third and last code that solves this problem. This code is similar to the previous one, but the only difference is this section here. Basically, we've put conditions to identify the EDI file. In this example, we are checking for a name in the physical file name to identify where it's from. Once we've identified the EDI file, we then use the setCurrentSchema method to tell the Freddy component which schema to use to process this EDI file. Remember, both the CEF files are already loaded here. We are not loading and parsing a CEF file at this point. We are just explicitly specifying which one to use. Let's run this program and see what happens now. Okay, it's done, and this time we get no errors. This proves that the EDI files were validated with their correct corresponding CEF file. For more example programs and to know more about Freddy or the framework EDI component, please visit EDIDEV.com. That's EDIDEV.com. Thanks.